Welcome back. Now let us do the supervised analytics using glmnet. And you may ask the question why we are using glmnet. See, we have the data that is sparse, and you can use the prediction through the algorithm that is very good and working with sparse data. And definitely there are many algorithms which works very well with the sparse data. And as per my experience, I have seen even XGBoost really works very good with the sparse data and many others. So you can choose any algorithm that works very good with sparse data. So let us start. Here I am using the glmnet so that I can explain something. Otherwise you can use other algorithm as well. The working methodology will be same. So now if you see that, if you recollect, in case of when we have work supervised, we used to divide the data in train and test, and train used to be around 45% and test used to be 15%. That is what we are doing in line 284 to 288. I'm running in one go, and we are attaching the library glmnet. That is what we are doing in 291. In 293 we are getting list of all the predictive variables, and glmnet need matrix. That is what in 296 we are converting the train from a data table to the matrix, and in 299 we are going to train the glmnet where this is the predictive data, this is the dependent data, and alpha 0.5. 0.5 means it is in between lasso and ridge, family Gaussian, a standardized false because we have the sparse data which is already in a normalized fashion. So 299 we are running it. Run is complete. Now let us predict. In 302 we are predicting it, and we are using the same object, and test also we had in data table, so we are converting to matrix. And 303 we are predicting it with this test data, where this is the object which we have got after fitting. This is our new data. Okay, and in case of glmnet it needs some kind of lambda variable. So this is the lambda which we have already, it is already there. Multiple lambdas are there. If you try to fit, I'm just trying to print it, and there's a multiple lambda, so I'm trying to work with minimum. I'll request you that please see the documentation of what is the importance of the lambda. The 303 we are predicting it, and just making sure it is a vector. 304, so we are done. In 307 we are calculating MAE, and 308 we are calculating RMSE, and 309 we are printing it at 0.61 and 0.92. And let before we interpret, let us see the summary. 3110. So if you see that this is on an average, it's 2.4 and MA is 0.64. So what is meaning of this? That all the predictions will go plus minus 0.6, and maximum it can go to 0.92. That is what it can go, and whether it is really making sense or not, that is the business judgment. And it is a Kaggle problem, so you can definitely submit the response and see where you stand. But right now please do not submit because this competition is closed. Now let us do the prediction, drawing of the graph. So let us draw the graph of actual and predicted. Actual is in the red color and predicted in the green color, so it is still printing. If you see, it is not that much impressive. It is not that much impressive. It has gone just opposite here. This piece of here also it has gone just opposite. Here it is looking good, looking good, looking good. This piece is also having huge error. Here also huge errors. So what we have to do it, we have to improve it. So just see that what is the data over here as well as here, and how can we really make it in a good way so that prediction happens here. So we should focus on the data at these observations. So that is what it is saying it. And you can detach it. One thing as classwork I would like you to do after this video, that we have drawn in the line. Please see if you can draw in the points and just see that how does it really looks like. And it is a simple regression. It is looking like a regression. So we can also do the regression over here, and this regression will be saved. All the data will be saved into the our folder image. So let us go and clear the image folder first, so that we can. So it is already empty. That's good. So now we are running the line 322 to draw the residual plot. Okay, it is doing it. See, it is doing, and still it is working. Okay, I think it must. Yes, it is almost done. It must have done something. Yes, at least it has done. See the QQ plot. I hope you recollect that all the data should be on this diagonal line. Diagonally, this line itself has not been drawn properly. So there is a good amount of improvement that is required in the model itself. And if you see the residual, these are having some kind of pattern. This is having also pattern. This is going in a haywire. Basically, it needs a lot of improvement as of now, if you see. That is what I was saying. You Kaggle problem, you think that it is easy. It's not easy, and it is very, very tough to work in the Kaggle problem. And as per my experience, for the first time when you work, and if you get in the top 75 percentile, it means you are doing very good. After working for say 1 or 2 years in the Kaggle, and if you are there in the top 25 percentile, you are very good. So that is the kind of things it is. Okay, so that's all, and in this way you can definitely do a lot of the advanced analytics. You can definitely use a lot of the other options. You can and I will also encourage you that you can visit the Kaggle site and see that what was the solution given by the winner, and winner generally publish their solution. That will also help you to understand a bit better in terms of knowing what are the things that can be done to improve the accuracy in the text analytics, plus what are the things really required to work with the text data and so on. And here I think this has given you the basic understanding, and after this all depends on you how much more you learn on your own and from the different sources. Thanks for watching it. See you in the next one.